Hi to everyone. Today in this lecture, we are going to learn about the unsupervised machine learning. As we know that machine learning is a process obtaining the machine with the some input data. That data can be labeled or unlabeled or unstructured data to generate some useful insights or specific result or some relevant information. So this is there are two types of machine learning. One is supervised and another one is the unsupervised. In today's lecture, we are going to discuss with the unsupervised learning. Unsupervised learning. What are the types of unsupervised learning? What is clustering in clustering and what are types of the clustering and common algorithms of clustering like K-means clustering, hierarchical clustering, and density-based clustering. These three are the widely used clustering algorithm in unsupervised learning. So now we will start. So as we know, in unsupervised learning, the input to the machine will be the unstructured set of the unstructured data and unlabeled data, and we will give up to it up to the machine to find out what what patterns will be there and what insights will be there. So this is there are no interruption from the outside world. Means what say there will be no supervisor or there will be no training data sets or test data sets to supervise machine. Hey, this belongs to this or this belongs to this. Unlike a like a supervised learning, here we are just giving raw data to the machine. That data like unstructured data and unlabeled data. So uh, there are two in supervised learning. There are basically two types of the input for the machine. That is one is unstructured data or unlabeled data. Unstructured data contains meaningless data and the missing values or on some unknown data. Unlabeled data uh, like example. In example we saw supervised learning example, we saw that we are going to we are having the set of images and we are uh, labeling the image with the name that if this image, then this image belongs to this set and this image belongs to this set. Here we are not going to the label data, so we are going to give a input only, and there will be the no target output or target input parameters. Okay. So so uh, we can here clearly we can see that what is label data. In label data, see that this set of the images having the cat image labeled as the cat and dog image labeled as the dog. And in our unlabeled data, we just input this data to the machine directly. Okay. So basically there are the three types of the unsupervised learning. One is clustering, and second in associative rule learning, and third one is the dimensionality reduction. In cluster based learning, we are going to group the unlabeled data into the into the some specific given data points or some cluster based on the these similarities. For example, we can say that if we are having the large data set of the customer for the e-commerce website, so we just find out the for the find suppose that we are going to define the three clusters like three trucks. So one minute. Three clusters like cluster one is uh, elect cluster one is hmm, cluster one is suppose that we are having the these data sets of the customer C1, C2, C3, C4, C5. This is the large data set from e-commerce. E-commerce. So what we what we are going to if we are going to find out the similarities and the hidden patterns between the customer behavior, like see, some customer will what electronics products, correct? Some customer will brought household items. Some customer will brought clothes. So this will be the centroid. This will this this similarity, we can say this similarity is will be called as the centroid, and we will cluster the data according to the this set, like C1, C4, here C, C1, C2, and so on. Okay, so this example is a very mm, further low data set, but then in general we are not having the small data set. We are having the very large data sets. So for this, there there we are going to work with the clustering algorithms. So, and second is association learning, rule learning. In that association, in these techniques there will be the some rule based ML techniques that will find out the very useful relation between the parameter of the large data sets. Okay, and third one is the dimensionality reduction. In dimensionality reduction, what will be happen, that in that we are going to reduce the unwanted parameter while preserving the most informative parameters as possible to to make a cluster. Like see, uh, we can say that if we have student data table, student table student table from placement cell, from for placement cell. So here see that what will be having roll number, marks, marks and address, of that student. Even sometime we will having the category. So in this case, what we will do further dimensionality reduction. What we will do, just a minute. Dimensionality reduction, what we will do, see, for the doing the uh, doing the analysis for this type of uh, data, the address and category no more required. So we will drop these features from the student table. We will consider only marks. Okay, on the marks we will make the make the relation um, uh, between the students. For that, what can be the result for this, that if suppose that is CGPA is greater than 7, then he should be placed less than 5. non-placed. Okay, 6 to 5 we can say. We can give some another specific set, like say that he have to give more tests or something like that. Okay, so now coming further, we will discuss in detail about the clustering. As we know, clustering is making a cluster between the some very similar data data grouping together. Okay, so as we previously said that what is the most appropriate example for the clustering more appropriate example for the clustering can be a customer shopping habit. Okay, so here we can see that cluster one this here can we say we can see that this data, if this is where household item and this is class item and this one electronic item, like the previous example we have seen. So this is the customer data, and after clustering we will find out the mm, most similarity between the customers and the who are the most similar. We will group them together. Okay, next one, there are the basically three types of clustering. One is centroid based clustering, second one is the density based clustering, third one is the connectivity based clustering. In centroid based clustering, we will organize the data points around a central vector known as the centroid. Okay, and in density based clustering, we identify the cluster areas of the high density separated by the region of low density in the data space. Okay, in the connective based clustering, we will build a hierarchy of the cluster using measure of the some measure of the connective based on the distance when organizing the collection of the item based on the their similarities. Okay, next one. uh, Here, these are the most frequently used algorithm for the clustering. Number one is the K-mean clustering, hierarchical clustering, density-based clustering, mean shift clustering, and spectral clustering. In K-mean clustering, uh, uh, we will group the data into the K cluster into the according to their closeness. Okay, in hierarchical clustering, we build a tree-like structure step by step, either merging or splitting the data. In the distributed clustering, this is also known as the TV scan. In this clustering algorithm, we group the data very uh, data the data which are very close closely packed together to make the mm, and to make out some cluster, and we will uh, we will make outliers and noise out of the space. Okay, mean shift clustering. In mean shift clustering, by we will move the points toward the most crowded area. Okay, this is a iterative process. In spider clustering, we will group data by analyzing correction and connection between points using the graph manners. Okay, now what process can be followed for the k-mean clustering? There are the basically uh, five process for the k-mean clustering. First one is the initialize, second one is the assignment, third one is update, fourth one is iteration, and fifth one is the convergence. Now will we see what the each process what we are going to. In initialization, we are going to start by selecting some random k points. Okay, or some mostly sometime it is most time it will be the given, or if there is not given, then we will use the algo techniques of the python. In the python there is the library there is a method in scale learn. In that, from that library we will import the this KMean method, and this will find out the uh, how many clusters should be there, and they will find out the centroid. Okay, next one is the assignment. In assignment, once we have find out the nearest find out the centroid, what center points should be, then we will uh, we will put the data our data points by the usually by the distance to the nearest centroid based on the industrial distance. After that, so once this irritation is done, then we will going to update the centroid of the each cluster like suppose 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 this C1, C2, C3. Okay, once we have group the data according to, like suppose that we have grouped the data, like for the C1 we have put like 2 comma 3 some data point 2 comma 3, and 4 comma 6, and here we have given that 8 comma 10 and 9 comma 7, and here we have for the example purpose only. Okay, 2 comma 2 comma 4, and second is 10 comma 11. So what is our third step? In third step we are going to update the going to update the centroid of the each cluster by the mean and mean, and we and the next and the by the mean of this, and the next centroid point will be the mean of this value. Okay, so in the first for the C1, what will be the centroid? 2 plus 4 by 2 comma 3 plus 6 by 2. So we can say now the point will be 2 2 plus 4 3 comma uh, 9 9 means 4.5. This will be the new centroid point for the C1. Like this we will update for the each cluster. Okay, now after that what we will do, we will we will do the iteration for the second and third until we will update do the iteration for the second and third, and in fifth one this algorithm will continuous this process will continuous until and unless uh, there is no we have not found out the predefined number of iteration, or there is uh, there is any change between the cluster. See what can be in the graph of the cluster, how it actually will happen. Suppose this is xy plane. So if we do the iteration like C, okay, so if do the iteration, so this will be the, we will iterate this one will be iterated as many as possible to find out the closest distance. So if there is no further iteration is required, there is no new center points or the data point, so it will be the final one. Okay, now moving to our uh, this is the this is the sample of the same high. This is one numerical equation that how we will going to solve the k-mean algorithm numerically. Okay,